Okay, Bismillahirrahmanirrahim. Today we will start from article number 7.1.4. Basically, this one is the second lecture after midterm and the 10th lecture. So, in this lecture, we will learn about local field, E local, and the Clausius-Massurti equations. So look, this Clausius-Massurti equation, this one is very important for polarizations or electronic polarizations, this sort of thing. So previously we have learned about the relative permeability and the electronic polarizations, and there are few terms. That one is the relationship between the permeability and the conductivity and these sort of things. Now today we'll basically start from the E local. So the localized field, that means the polarizations in between two, that means two atoms, that one is known as the local field. So this local field is derived as E local equals to E plus 1 by 3 epsilon naught P, where P is the polarizations. Although the derivation of this formula is not available here, but this one is not too much difficult. So this one is known as Lorentz local field in dielectrics. So this one is the localized electric field equals to E, that is to electric field plus one third epsilon naught P. So I will also upload another derivations or another just one page derivations. That one will from there you will learn how you can derive the Clausius Mosset equations. Okay, just remember E local equals to E plus one third epsilon naught into P. Now look, from the definitions of Lorentz field, the induced polarizations P induced equals to alpha E local. Okay, and from the previous definitions, if you can remember, that one is P equals to uh, that means chi epsilon naught E, and we know that this epsilon R equals to 1 plus chi E, so we can also write down chi equals to epsilon R minus 1. So we have just put this value P equals, if we put this value here, then we will find P equals to epsilon R minus 1 into epsilon naught E. And look, the total polarizations, that one is defined as P equals to N in P induced. Okay. Now from these two equations, we can derive that epsilon r minus 1 divided by epsilon r plus 2 should be equals to n alpha a divided by 3 epsilon naught. This equation is known as Clausius-Mosset equations. So I will upload the derived format of this equation, so you can also check these things from that uploaded test. I have derived these things step by step. You can check that things from that image. Okay. Now after that, so this equation is very important. This equation is very important. Okay, and there will be various words. That means in few equations you may be asked to find out the epsilon r. That means the relative permeability in terms of these two things. Then you have to just so you know how to derive this thing. You have to just cross multiply, then take the commons. So all the epsilon r should be in single stage, then divide. So there will be a few definition, few formulas that you need to be derived from here. Now, so you know the electronic polarizability of the argon atom is given like this. What is the static dielectric constant? So that one you are asked to find out the epsilon r. So if you look at these equations, look, if you look at this equation, that this one is a single epsilon r. So you can, if in any exam, if someone asks, prove that epsilon r equals to this from Clausius-Mosset equation, prove that epsilon r equals to this. So this is nothing but some mathematical calculations, isn't it? So I think you can easily find out these sort of things. Okay. Now, if we move to article number 7.2, That one is the electronic polarizations in the covalent solids. Look, the electronic polarizations are the polarization is basically found in covalent bond. Actually, in case of ionic bond, there is no too much polarizations, or actually there is the net polarizations value should be equals to zero. We will also learn this thing in our today's lecture also. Okay. So look, if we have some covalent bonding, then we will find that there will be some tendency of moving this electron from once either in the positive side or in the negative side, or that can be defined as the polarized side. So this example 7.3, this one is very important. That one is the electronic polarizability of the covalent bond. These values are given here. Look, using the same formula. Look, using the same formula, if I ask, prove that alpha E equals to this, prove that alpha E equals to this. So this, look, this one is nothing but a simple calculations from the Clausius-Mossetti equations, isn't it? So do not forget to derive the Clausius-Mossetti equations and the related terms uh, from this alpha E. So I think you know what is the Clausius-Mossetti equation? Epsilon r minus 1 divided by epsilon r plus 2 should be equals to n alpha E divided by 3 epsilon, isn't it? So from there, you might be asked to find out different parameters. Okay, so we know also this formula. So I think these mathematical problems won't be too difficult for you. Now, in article number 7.3, the polarization mechanism. First of all, that one is the ionic polarization. So look, so what is called ionic bond? Ionic bond means we know that one will be donor atom, another will have some acceptor atom. So the donor atom or the donor uh, that is element, it will, that is, say for example, that one is sodium, so sodium will donate the electron, and if that one is the chlorine, so chlorine will accept the electrons. So if sodium donate the electron, that will be positively charged, and chlorine accept an electron, that will be negatively charged. So the net polarizations in terms of ionic polarizations, that one is, there will be some positive part and negative part, and the net polarization should be equals to zero. But in case of covalent bond, there will be some polarizations. So the in the ionic polarizations, P average, so P average equals to alpha I E local, the same formula as before, and that one is the ionic polarizations. And same way we will find that P equals to Ni P average. So the formula that we have already derived in the dielectric materials. Okay, so P equals to epsilon r minus 1 multiplied with epsilon naught E. So look, the Clausius-Mossetti equations for the ionic bond is exactly same. Only the difference is that one will be Ni and alpha I, and the rest of the part is same. Okay. Now the orientation of the dipolar polarizations. So in this case, that one is actually the covalent bond, and in the covalent bond there will be some uh, something P equals to N P naught, and there will be another dielectric constant. That one is the orientational polarizations, and from here you know the torque formula tau equals to F sine theta, and P equals to, from there if you integrate this thing. So similarly, you will find that P average equals to one third P naught square E divided by KT, and AD, that means the dipolar electrical polarizations AD should be equals to one third P naught square divided by KT. Okay. So next one will be the interfacial polarizations. So these are the different types of polarizations. Uh, yeah, we know that if that one is the two electrode, this one is the dielectric material, and there will be if we apply some electric field, there will be the accumulation of charge in the negative that means the electron will be allocated to the negative side, and the another that means the proton or the uh, donor, that one will move to the positive side to neutralize this thing. But there will be some polarization. Okay. Now the total polarizations P average should be equals to, this one is the dielectric polarizations, this one is the ionic bond polarizations, and this one is the interfacial or the uh, another covalent bond polarizations. So the total polarization P average should be equals to the summation of all these things. Okay. So again, the Clausius-Wilson equation should be like this. So using this formula, you have to also solve the example 7.4. Okay. So this will be our 10th lecture. So in our next lecture, we will start from the frequency dependent dielectric constant. Okay. So now this up to this one is from the book. Now I will also show you something that one is from the board professor's lectures. Look, first of all, that one is the localized field. So we have also learned the E localized should be equals to E localized equals to E plus one third epsilon naught P. So this one is the summarized part of our or the summarized part from the book. Next, the electronic polarizations. Next, the ionic polarizations and orientational polarizations. Then the interfacial polarizations. And if you, this one is the total polarization. So if anyone wants to go through these lectures, you can also go through this lecture. So these are the notes. I will also upload these things in your Google Classroom. Okay. So up to this one will be your 10th lecture. So in the next day, I will upload the 11th lecture. That one will be the frequency dependent dielectric constant and the dielectric losses. So please solve the numerical problems by yourself. Okay. Thank you.